First, we have to define what a quadratic equation is. So let's go ahead and do that here. A quadratic equation is an equation that can be written in this form right here. A x squared plus bx plus c equals 0. An important note here is that the exponent on the highest exponent that you see there is a 2, right? And you have to have that term for it to be a quadratic. Okay, and that's why we say we don't want a to be 0, otherwise that would take that term away. It would make it a linear equation at that point if it did not have the x squared term in it. Oopsie, excuse me. There are a couple of examples here of quadratic equations. The first one is not exactly in this standard form where we have it equal to 0, but that's easy to fix by subtracting 6 from both sides, and you get 5x squared minus 4x minus 6 equals 0. And so it's in that form where a is 5, b is -4, and c is -6. Okay? This one's already in the standard form where it is equal to 0, and you have a is 8, b is 0, and c is -7. So just a couple of examples there. You could see more complicated things, certainly that would still be quadratic equations. Let me give you another example. Let's suppose we had something like x minus 3 quantity squared equals 15. Well, that as it is doesn't look like a quadratic equation, but it is because if you were to multiply that out, if you FOIL out that x minus 3 times x minus 3, you will get an x squared as your highest degreed term there. And so that will simplify down to something in that standard form that you see. Okay? All right, so once we recognize that we have a quadratic equation, we have to know that we want to solve it. And so we are going to look at 4 methods for how to solve quadratic equations. The approach is very different from a linear equation, so that's why we have these different methods. The first method is factoring. We use this when the quadratic can be easily factored, and the reason it works is because of this fact that you see in the box here. If a times b is equal to 0, then a has to equal 0 or b has to equal 0. The only way to multiply two numbers and have it equal 0 is if one of them is 0. There's no way to multiply a non-zero number times a non-zero number and get 0. Okay, so that's what we're doing here. The example here is that we have x minus 3 times x plus 8. So this is kind of like our a above, and this here is kind of like our b above. We have a product of two things equal to 0. We're going to set each of those things, those factors, equal to 0. And then we have a linear equation that we can solve by adding 3 to both sides here and adding subtracting 8 from both sides here. We get two solutions to our equation here. Okay, so that one's not too bad because it was already in factored form where we had a product of two things equal to 0. Here I don't have anything equal to 0, and it's not factored. So a couple of important things about this fact that we have up here. This does not work if a times b is equal to anything other than 0, a non-zero number. It doesn't work. So let me give you an example. Let's suppose I have a times b equals 15. Well, that certainly doesn't mean that a equals 15 or b equals 15, right? That doesn't work. Because the product of those would be 225, not 15. So a could be 1 and b could be 15. A could be -3 and b could be -5. It doesn't tell us anything if this number isn't 0. If it's 0, that's when we have the ability to use this property. Okay, So what we need to do is we need it set equal to 0. We need it in that standard form. So we subtract 2x from both sides, put this in descending order, and we get x squared minus 2x minus 8 is equal to 0. Then we see if we can factor it. And we can factor this into x minus 4 times x plus 2 equals 0. Remember, to factor that, you're looking for two things that multiply to give you negative 8 and add up to negative 2. Those would be negative 4 and 2. And then once we have a product set equal to 0, then we can set each factor equal to 0. X equals 4, x equals negative 2 are our two solutions here. Okay? Remember, feel free to pause this video at any time if you feel like you need to either go back and review, backwards, forwards, whatever you need to do to feel comfortable with this material. Okay, a second property or a second method for solving quadratic equations we're going to look at is the square root property. This one is commonly used when b is equal to 0. That middle term is missing if b is 0, right? And it comes from this fact. One thing that's important here is that this u that we have here could be an expression. It could be x plus 6 inside that quantity that being squared. Okay, we can use that. I'll show you what I mean here in a little bit. Let's start with this guy. This one doesn't factor, so I would be looking at a different method other than factoring, and I would add 8 to both sides. That's a little bit different than our factoring approach where we always want to have it set equal to 0. We're kind of making this not equal to 0. But we're doing that because we can use that square root property and we can say, hey, let's square root both sides of this equation. That will give us x equals the square root of 8. But I'm missing something up there. What did I need up above? Yeah, the plus and minus. I need to put that on there. So I have a plus or minus root 8, which of course I can simplify into 2 root 2. I think an important thing to note here is that so far we have had 2 solutions on our first example, 2 solutions on our second example, and now we have 2 solutions to this example. Okay? With a quadratic equation, you will have at most 2 real solutions. You could have 1 real solution, you could have 0 real solutions, but you're never going to have 3 or more, okay, with a quadratic, if it truly is a quadratic, where the highest exponent is 2. Okay, here's what I was talking about before, where I could have a quantity squared, and I can still use that square root property and say, hey, I'm going to square root both sides of this, not forgetting my plus or minus there, which on the left side, when I square root the square, I get that x plus 3. Technically, it's equal to the absolute value of x plus 3, but we're taking care of that with the plus minus. So here you don't have to worry about that with this equation. The square root of 16 is 4. I want you to be really, really careful here. I want you to break this into 2 separate equations and solve them separately. Subtract 3 from both sides of the equation. Here you get x equals 1. Here you get negative 7. The reason I say that is because sometimes I'll have students subtract 3 from both sides of this, and they'll say the answer is plus or minus 1, just taking the 3 away from the 4, and that's not correct. You have to subtract 3 from positive 4 and from negative 4. Notice again, 2 solutions here. All right, sometimes you have a little bit more involved, but here's another one where the b is 0, the x term is missing. We're just going to isolate that x squared. Add 27 to both sides. Divide both sides by 6 to get the, whatever you have squared, you want that by itself. 27 divided by 6, which simplifies to 9 over 2. Those are both divisible by 3. And then you use your square root property. Square root. Don't forget your plus or minus. That's the biggest mistake I see in students in this. Square root of 9/2, or you could say the square root of 3. I'm sorry, the square root of 9 is 3 over the square root of 2. If you want to rationalize the denominator, or if your directions inside your homework say rationalize the denominator, you'll want to multiply by root 2 over root 2 to rationalize that. I'm not sure what I'm doing there, where that came from. I'm multiplying here by the square root of 2 over the square root of 2, which is just a fun form of 1. And then root 2 times root 2 in that denominator gives you the 2. 2 solutions again. Okay? I think it's important before we move on here to talk about a situation where you don't get 2 solutions, because we have seen a couple of examples with, or every example we've seen has had 2 solutions. So I'm just going to make up a problem here, and let's solve x squared minus 6x plus 9 equals 0. Okay? Well, I don't want to move that 9 over because I have an x squared and an x term. And so I'm going to try to factor this. This does indeed factor into x minus 3 times x minus 3. Because I'm looking for 2 numbers that multiply to give me 9 that also add up to -6. So I have that. You could write that as x minus 3 quantity squared equals 0. And now you can either use your square root property or your factor, that factor theorem where you can set the factors equal to 0. It doesn't really matter. You'll get the same thing. I prefer the factoring x minus 3 equals 0. The other factor is x minus 3 equals 0. That doesn't give you a different solution. X equals 3, x equals 3. So you get one solution here. We would say this solution has multiplicity 2 because you get it from 2 different parts of this equation. So that's, there's still kind of 2 solutions hidden in there, but it's just only one distinct real number. Okay, so that's how you might get something like that. Notice here we had, if we square rooted both sides of this instead of doing the factors, we would have plus or minus the square root of 0, which is just 0. There is no plus or minus 0. So that's why we only get one solution there. Okay.